Welcome. We are mazed and confused, and in this video, we'll walk through a tilt-controlled maze game built entirely out of the Freedom KL46Z development board. No screens, no joysticks, just motion and LEDs. This project brings together elements of embedded systems, sensors, GPIO, interrupts, and real-time feedback, all working together to create an interactive maze game. The objective is simple: navigate a 5x5 grid maze from the top left corner to the bottom right goal square. But there's a catch: the player must navigate using tilt gestures alone. Motion is detected using the onboard MMA 8451 accelerometer. It outputs raw x, y, and z values over I squared c. Our software polls these values about 5 times a second and classifies tilt into one of our 4 directions: up, down, left, or right. If the tilt in a direction exceeds a threshold, we map it to a move attempt in that direction. The maze is randomly generated every time the game resets. Walls are placed with a 30% probability per cell, but the start and goal cells are always guaranteed. Each tilt triggers an attempted move, like that. If the direction is valid and not blocked by a wall, the player's position is updated. To make gameplay intuitive without a screen, we rely on LED feedback. A red flash indicates a wall hit, like that. Green means a valid move, like that. Reaching the goal triggers a colorful celebration with all LEDs blinking in sequence. So we will try to navigate this maze. Oh, it seems to be a difficult maze. There we go, we have reached the goal. Now there is a reset button. Players can reset the maze anytime using that button. This triggers an interrupt on in the falling edge, sets a flag, and waits until the game loop sees it. When triggered, a new maze is generated and the game starts over. There, and you can try it again. Behind the scenes, the system initializes I squared C for the accelerometer, GPIO for LEDs, sets up the interrupt controller, and handles LED timing using ARM assembly delay loops. This project brings together key skills: embedded C programming, low-level device interfacing, and designing interactive systems without a screen. Perfect training for real-world firmware development. Things that we wish we would have known before starting. We had a bit of trouble with LEDs and the timing, and we had to take a bit of time to figure out the clock cycles of our board. From sensor data to LED feedback, everything runs on the board, no PC required. Thanks for watching, and I hope this inspires you to build something hands-on and fun.